From ContainerDays Hamburg, this video is proudly presented by Dockerized.
In the beginning, developers created the software and the infrastructure. Their code was without form, and darkness was over the face of the deep, and the Spirit of God was hovering over the face of the files. And there was evening, and there was morning, and their software worked on their machines. And the developer said, let there be an automated build. And there was an automated build, and they saw that it was good. And the developer said, let there be a CI. And there was a CI, and they saw that the CI was good. And there was evening, and there was morning, and a repeatable build was possible. But when the automated build was promoted to production, the developers looked upon it and were greatly troubled. For behold, what worked on their machines did not work in production. And the developer said, let there be an environment in the midst of the chaos and let it emulate production. So the developers separated the configs that were under the local code from the configs that were about in production. They call it the 12-factor app. And there was evening, and there was morning, and a staging environment was created. But when the code was deployed to staging, the developers looked upon it and were greatly troubled. For behold, staging was flaky and not paired with production. Well, my name is Manuel De La Peña. I hope you enjoyed this little story and never found yourselves in that situation, which is very common with staging. I work at Docker as a staff software engineer in the open source team for clients of Mobi. I previously worked for Atomic Jar, was a company was acquired by Docker in 2023, and I'm the Testcontainers maintainer since 2020. Today I'm going to present the library. I don't know how many of you use Testcontainers or know about it? A couple of raise hand, cool. Thank you. So what do you want to, I want you to exit this room with this. So understand that integration testings are fast. Understand the issues that we have as developers to run these integration tests. Discover Testcontainers. This is the first time you touch it. Pray to demo code because, of course, will be live demo. And also enjoy this juicy time with integration tests. First, you know the pyramid of testing, right? It says that 70% of the tests should be unit, 20% integration, and 10% end-to-end. There are a lot of confusion or discussion about what is a unit, what's an integration. The line is so blurry, at least to me. But with modern tooling, the pyramid is outdated, so it's not valid anymore. In 2016, Guillermo Rauch, the Vercel founder, put this tweet: more integration tests. So the resulting, or what I have seen in the industry, is that this is the current situation for the testing pyramid. A lot of integration, end-to-end, unit, and static analysis code, linting, etc. So in Go, we have interfaces, and with mocks, we can simulate error conditions. For me, this is totally valid. But if we abuse mocks, then we could be just lying to ourselves. That's why integration test comes to play and resolve that. The issues that I solve as a developer is that sometimes your application depends on third-party systems, third-party dependencies like databases, NoSQL databases, SQL databases with the hype of AI, vector databases, cloud providers, authentication services, queues, etc., whatever. How do you start that project? How do you verify that the feature that you're building integrates with that dependency correctly? You have to spin it, probably as a local process in your host. You can create a VM and talk to it, to that VM, configure it probably with background, or deploy it in the cloud and get it. If you're lucky, this cloud provider gives you the database in a couple of hours, but it could be weeks or months, depending on the process of your company. The second issue could be running the tests. If you write a lot of tests, because I hope who's writing tests? I write tests. A lot of them, all of you, all of the hands raised in the room. but you write a lot of tests. Are you running them locally? Sometimes it's not possible. Why? Because we have so many dependencies, and we have to start them all to run the test. So we just push the commit to the CI server, to GitHub, and the GitHub action, Jenkins, GitLab will process it. And we go back to our stuff. 2 hours later, the CI is broken. We have to switch context, resolve the fix, resolve the error, investigate, and then go back. So we are switching context for that. So my idea was I would like to have something to be able to run the test locally. The third issue is about config management. The versions that are in production are the same that the one that are in this staging environment that I mentioned before. Who's maintaining those versions? A platform engineer, the development team, who is in charge of that? What packages are you using in that project? Sorry, in that service? The dimensions of the CI worker that you are running the test. Much memory. We are talking about containers. How many containers can you run at the same time in the CI worker? Who is dimensioning that? Hopefully, with GitHub Action, you can do it yourself. But sometimes, you instead of working in features, you are working more in the CI or in another team, and there is a handoff people that needs to update the CI. And the last one is issue that I found as a developer is granularity. Are you able to run just one single dependency of your application? If you are lucky, it works in one service now, nothing more. One service with one single dependency, you just run it. But in a microservice architecture, you are running multiple services. Probably you have a Docker Compose file, and you start everything, and well, your machine can hit your coffee really, really soon. Are you able to run one single test for one single dependency? Sometimes it's very difficult, because I need to run the entire system to run the test for a database, for example. So what would I like to have? Something that allows me to avoid mocks when possible. As I said, mocks are really important in Go. And for me, to get to failure modes, demonstrate that those failure modes are happening is the right thing to do with mocks. Sorry, excuse me. Also, I would like to have the versioned in code, the dependencies. I'm talking to Postgres 15. I would like that version of Postgres be in my source code. So I would like to define the dependencies explicitly when they are used, for example, the test. I would like also to have a local environment that allows me to work with the application, just start the application with all the dependencies wired if needed. So we would like to create a clone and run experience, which is I just clone the repository and I run the test. And this is important because then the onboarding process of a new project is super seamless. You have new developers that clone the repository and run the test. They don't have to install this project, run this script, apply this, I don't know why. And most importantly, the CI server is another developer in the team because the CI server just clone the repository and execute the test. So enter Testcontainers Go. This is the promises that we try to resolve. Testcontainers is an open source Go library that you import in your projects and allows you to have a programmatic access to the Docker engine or Docker engines. You can create, build, start, stop, terminate containers in your code, and also giving you these benefits: consistency, data isolation, and build speed. Of course, consistency, thanks to containers. The containers will be started and killed. So thanks to containers, we have this immutability of the dependency that we are interested in. You don't need to install the process in your host. Back in time when you had to install Oracle in your machine, PL developer, and start the database locally with my custom configuration. No, not anymore. I just install, I run a container, and I don't have to configure something that probably my coworker could have a different configuration. Also implies a better developer experience, onboarding experience, sorry, because there is more readability. I will show you later. And also, as I said, the CI is a new developer in the team. Talking about data isolation, well, you choose. For me, it's here in the last, it's in the last line, but tests are code that need to be designed. We developers architect perfect system, the quality is amazing, but we just add a new test. Let's add a new test, add a new test, without this mindset of designing the test suite. So one of the major questions that come to me when on Slack, on GitHub issues is, should I put a container per test function? Should I put a container per test suite? Well, it depends. It depends. So depending on what the team needs, I would recommend put a container wherever you need it. So, for example, if you want to have total isolation between tests, no data corruption, just put a container per every test. But probably that causes a lot of congestion, spin up a lot of containers. So it depends. I will start with that. But thanks to containers, we have this isolation. So there is no more data pollution. When you write in tests, you must make sure that the test creates its state and removes that state after the test finishes. And build speed. We're talking about containers. We know how fast it is to start a container. Of course, depending on the image. If you're talking about the image that is 4 gigabytes, then, well, it's not that fast. But there are images with 4 megabytes. Also, the caching system of the container registries, the OCI artifacts, allows you to pull images and reuse whatever layer are already in the system. So the pool could be helping you out in speeding up the build. Let's go deep into Testcontainers Go. Testcontainers Go gives you random ports for all the exposed port in a container. So you declare programmatically, not declare. If you programmatically say, I want this Postgres with the well-known port 5432 exposed, Testcontainers will give you a random free port in your host. Why? Because that will enable you to run tests in parallel. Multiple containers of Postgres running at the same time. Makes sense. Probably in your use case, doesn't make sense because you have a huge Postgres database with huge SQL file, but you are able to do that if you need it. And also comes with the concept of with strategies to reduce the flagginess. When you are in the CI, how many times have you put a time sleep one in the CI? Because the test runner is super fast, although the container is not ready. And 2 weeks later, time sleep 2, time sleep 4. Let's double it, right? Well, this is because the container is not in the readiness state, and the CI and the test execution is faster. With the concept of wait strategies, you programmatically say, wait for this port to be available in the container. Wait for this log entry to be present. Wait for this file to be existing inside the container. For example, for Elasticsearch, it contains a TLS certificate inside the Docker image. And to create a TLS connection to that container, you can wait for this file to be then extracted and create a client and execute tests using TLS, for example. Or you can combine for all. You can combine multiple of them and execute them at the same time. Once those strategies has passed, then the container will be ready. So you don't need this time sleep. More APIs. You have copy APIs, copy file APIs, sorry, where you can copy files from the container and copy files out the container. Also, there are certain lifecycle hooks in a container. You can start a container, create, stop, terminate. You can execute your own code before or after those hooks. Imagine that you need to, for example, log something with the container. You create this hook, you append it to the code, and that will be executed thanks to Testcontainers lifecycle hooks. If you are also a heavy user in Compose, you don't have to change anything. We have Testcontainers has a compose module that you point to it, and test container will manage the lifecycle of compose for you in code. And finally, it comes with a garbage collector already included. Every time you start a container, or a test using test containers, sorry, a companion container will be started for you. The name is Ryuk. It comes from the anime Death Note. So every time a container is added, we take a note, and at the end of the test execution, we kill that container. It applies to containers, images, networks, and volumes. Well, that is cheap. PowerPoint supports everything, no? So let's pray to demo gods. Big enough in there? Can you read it? I can make it bigger. Well, oh sorry. Let me explain this a little bit before. This is a sample application. I will share the links later. Very simple, very stupid use case. Sorry, Nikolai, we are not using the PG outbox pattern here, but we have a Postgres database, a cache using Redis, a queue using Redpanda, and also this application talks to AWS to calculate some maths in a Lambda. Pretty easy. But we found a bug in Postgres. In the Postgres, not in Postgres, in our persistent layer database. As I said, if you are using other approach, you go to a shell before that, and you start with Docker Compose, with Kubernetes, with a shell script, and start your application. But you don't need probably to execute Redis, execute Redpanda, or talk to Cloud Emulator on AWS. No, you just need Postgres. So this is the code, very, very, very simple. I'm using the repository pattern. I'm storing here the client connection to Postgres using the jackc driver. And this repository receives a connection string. So whenever I create a repository here for Postgres, I will receive the connection string. Why? Because I want to inject this dependency at test time. So in production, when I create this, I create here, metadata. Here I'm reading the environment variables. This is the location of the database, the location of the Redis, but at test time, I want to use the container that Testcontainers is giving to me. So here in the repository, pretty simple SQL, create, exist, get by UID, right? For test, I'm using the testing library here from the standard library, the testing package, sorry, and also Testify for assertion for simplicity. I'm gonna use a Postgres module from Testcontainers, which use a functional options pattern. You can use run with the image, or you can customize with whatever you want. For example, with init scripts. In this case, I'm gonna tell Postgres to execute this first. Every module comes with APIs that are related to the given technology. I will show you the list of modules later. I want to start with this database, with username, with password. I'm gonna wait for the container to this log entry to appear in the log 2 times. It's something specific to Postgres. So I'm gonna run this, and I have subtests. I'm creating the container just once, and I'm gonna execute multiple subtests. In this case, just create and exist, and does not exist. Because in this case, as I mentioned before, remember that the test data pollution is very common, but in this case, the tests are independent. So let's run this. I'm gonna make sure I have a container runtime, I have the image, I don't have anything else. So I already pulled the images to not lose time in the demo. And well, let's do how long does it take to run this test? It could be 1 minute, 2 minutes. Let's see. very simple, but in 4 seconds, I have the confidence that my code is doing what is expected. At least the test could lie to me. Of course, I could say assert true, true, but I'm inserting a talk in the database, and I'm checking that the new talk is there. I'm retrieving it, and the data is there. I could also put a breakpoint, and for example, here and inspect the content of the container if you are interested in it. So if I debug it using the capabilities of the IDE, in this case I'm using Cursor, but it could be VS Code. I have a breakpoint here. And at that time, I have here 2 containers. Ryuk, this is the one that I mentioned that is taking notes of all the containers and volumes and images. And here, for example, I can see the logs of progress. I can debug it and enter a shell inside. I can inspect the files of the container, etc. Because the breakpoint is 2 minutes. Is stopping the execution of the test program, the Go test program, and I can do whatever I need. Let me jump to another execution of the test. For example, for AWS, for me this is really important use case. How many of you are working with lambdas? Lambdas? Well, it's a use case. You build your Lambda, you have to deploy it to AWS. You have to package into a zip file, you have to upload it to AWS, you have to verify that it's working, etc. So here I have a really simple Lambda code, which is using the Go packages to Lambdas, which is doing some math. It receives this payload, it responds with this. Calculate the average from that payload and the total count of that payload. Really, really stupid. So imagine there are 2 teams, one in the Lambda and one consuming the Lambda. The Lambda could execute local stack, which is a project that emulates the majority of the services in AWS. And I'm going to run this test. Let's see how it goes. I'm going to run all of them. It will I have a makefile that builds the Lambda and zip it. So this test is calling, let's see, sorry, here, main test, sorry. It's building the Lambda, calling make zip, and it will use local stack container in the latest image. It will apply some environment variables that are needed for this execution. In this case, I'm going to apply the Lambda to the services that are present in local stack. I'm going to copy the zip file that was generated into this location, tmp function.zip. This zip file came from the makefile. And I'm going to add some lifecycle hooks to this container, which is after the container starts, create the Lambda. So I call this, execute this inside the container, AWS Lambda, create function, blah, 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 create the function URL config, wait for the Lambda to be ready, execute those commands, and then list the functions and parse the response into this struct to calculate the URL of the Lambda. And at the end, I replace with the mapped port of the local stack, because remember, local stack or test container will give you a random port. It will replace with the URL of the Lambda that local stack internally knows, but externally is mapped to a different port, and I get the URL finally. So I can call this URL doing HTTP and basic HTTP client. I will do a curl to that URL, and the response should be this, because this is what I expect from the passed payload. So let's see the test. And in 19 seconds, I'm able to iterate and deploy things to AWS locally, of course, with this emulator. Local stack is really popular. But never trust a test that never fails, so that you haven't seen fail. Let's introduce a bug here, and let's calculate the average with a bug. So if I run this test again, the log is executing here, creating the container. If we go here, we see the logs from local stack doing its magic, creating the Lambda, get the function, etc., blah, 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 and finally, bug. Because I added a wrong math operation. So in 18 seconds, and 18 seconds is a lot for in unit test, but remember, we are doing a really heavy operation, which is uploading a zip and creating a lambda. So in 18 seconds, I have confidence enough to make progress with my project and detect errors the soonest. Let's go this back, let's put this back, and let's jump to the end of the presentation. What about dev mode? Do you want to go run and have all the dependencies wired for you? I will add there are two links here, how to enable local development with test containers. One for plain applications, regular applications, and another one with GoFiber. I contributed to GoFiber, if you are familiar with GoFiber. And since V3, you can add test container support under the hood, built in the web framework. So it's really, really cool. Basically, it's using init functions and build tags. At the moment you protect a file with init functions and the build tag -dev, for example, you can start dev mode with all the containers that your application needs. In this case, for example, going fast, I have this dev dependencies file protecting the file for running end-to-end tests or for dev mode, and it's starting the services that I need. Create the database, the Redis, the streaming queue. Just for reference, you saw the Red Panda, the local stack, which is a really consistent example, but to run Redis, is this just one line. Nothing else. There is a QR code with the Go workshop explaining the application that we saw the test. There is a modules catalog here with all the services that we provide a module, which is a Go package that you import. For example, cloud emulators for Azure, for Google Cloud, for AWS, NoSQL databases, or relational databases. We have these ones. NoSQL databases, a lot of them. Vector databases, a lot of them you're doing this hype of AI. Message broker, we have RabbitMQ, Redpanda, Kafka, Artemis. We have web emulators with WireMock, ToxiProxy, which is also interesting. If you want to add toxics into your network, you create a Docker network, you put some containers, your application needs to be resilient to reducing the bandwidth or losing packets, then you can add ToxiProxy in the middle and redirect and understand how your application behaves under network flagginess. Lots of them. And as I said, this is basically it. So workshop, the local modules catalog, and the website is also in the pkg.go.dev, but we maintain another curated doc system with mkdocs, where we are more free to add our examples and code. The project is getting popular, so I will appreciate if you like it. If you really like it, start it. And basically it. I don't know how long we're on time. Perfect. Thank you.
Perfectly in time. Manuel, thank you so much. That was a wonderful talk. And there's a bunch of questions for you.
Cool.
So let's start the Q&A session. So can you use other languages than Go with test containers? Because they have a lot of Java or .NET applications and not so much Go.
Really good question. The project started in Java in 2016. And all the concepts that I explained, I applied it to those languages. So you switch from one project to the other, or one company to the other company, and you work in Java, .NET, Node.js, Go. There is, can I share the screen? Yes. If you go here, you will see Java, Go, .NET, Node.js, Clojure, Elixir, Haskell, Python, Ruby, Rust, PHP, and Native, which is a recent addition to. And I have to say that Java and Go, Docker pay us to maintain this, but the other one, community maintain it, right? So it's a best effort by the community. In that sense, if there is Go, Java, if there is a bug in Go, Java, you can go and ping me and chase me. But the other ones is community maintained. Yes.
Awesome, thank you.
Podman support. Cool.
Podman
This is
support.
also good one. Theoretically, yes. At the moment you give us a Docker socket and a Docker compatible API, 100% compatible with API, with Docker APIs, then it should work. We have guides. Can I share the screen, please? We have system requirement Podman. With Podman, you can basically, you need to start Podman. In macOS, you need to remove you can add the privilege to the container. Ryuk is the container that is removing the other containers. And for Fedora, you need to export. So there are some tricks that you need to do, but for Podman, but it should work.
Can the test containers be spawned on an existing Kubernetes cluster?
This is a good question also because, well, plenty of good question. Because then it's Docker in Docker. So the reason is, why do you need, because the CI is running in Kubernetes? That's the question? Yes? Yes, that's... probably we need to, I can elaborate it later because it's very, well, probably a long answer. It's difficult to do that Docker in Docker, but you have to mount the Docker socket into that container or that pod or that, well, I'm not a Kubernetes expert, but you have to mount the Docker socket there and be able to do that. But we can talk a little later.
Okay, the next question goes a little, maybe it's also a longer answer. Let's see. Does test containers work with any container engine?
Same question, same answer as with Podman. We have docs for Colima, Rancher, or Stack. Ideally, and this is something that we are working internally in Docker, we're support any Docker context. At the moment, you give us a Docker context active, and the location the Docker of a Docker socket compatible API. Test containers should work out of the box. So I have locally tested with Orstat, Colima, Podman, Rancher, and even with an embedded runtime that we were building at the company before Docker acquired us, and it worked. So it should work. But if it doesn't work, please open an issue. So this is it's an open source project. So help us in resolving that, because we are more than happy to support whatever is not supported at the moment.
Awesome, thank you. Can I simulate a GitLab instance with test containers?
If there is a Docker image for that, I already showed the modules, but there is the concept of generic container. Generic container is basically defining the internals of a module is using a generic container, is the struct that we use, and this struct you fill it with whatever you need. You post the image, there is a GitLab 7, GitLab, I don't know the version, and the proper environment variables to start this GitLab, then why not? If you are a GitLab user, why not contributing a GitLab module? That will be also always on.
Awesome, thank you. Does it support container snapshotting for faster container startups and faster test runs?
We expose, in test containers, you have access to an internal Docker client. So if you are able to, if you need it, you can commit the state of a given container and start from that state. It's not supported at the first level API, but for example, for the Olama module, we do that. The Olama module does that whenever you load a model to start from that point where the model is already loaded and you don't have to load the model again. So it's possible. So there are examples, and Olama module, if you like to check the code, is there. But we expose the Docker client. So at the moment that you get the Docker client, you can call all the APIs from Docker.
Awesome. So what status of reusable containers features in Go? Is it relevant to local stack, which is quite slow to start?
This user already used Test Container Go, I'm pretty sure. Reusability is tough because, as I mentioned, we want test isolation. But sometimes, depending on the state of the container, we need to keep that state because the container is super slow to start, etc. And we have an experimental feature which is in reusing containers. In Go is by container name. In Java, for example, is calculating the hash of the representation of the object. We're working on that also for Go for more consistency. But at the moment is by name. So at the moment you mark a container for reuse, there is a functional option, is with or reuse container, reuse by name, I think. You put the name, and the container will be reused by name. So that container won't be killed by Ryuk and will be again after you kill it.
Wonderful. So actually, we are kind of done now with the QA time, let's say.
The second one.
The second one, I mean, great talk, I agree.
Let's. Yes.
Can you compare to a competitor project? That maybe is the last one?
The last one.
And then Jose and the person having the autopod selection question, you are still, Manuel, you are still here today and tomorrow, right?
Today and tomorrow. So any question, just let me know. About this is the comparison. Is for me, it's an internal metric. I know that DockerTest is doing a great job. The thing is that we are getting almost as popular. So it's not me, it's the community. No, thank you. For me, it's amazing sharing this with you, because if you are happy using the project, I'm really happy. This is what we work for.
Manuel, thank you so much. We have to quit, unfortunately. Yes. That's again your applause.
Thank you. Thank you very much.
From ContainerDays Hamburg, this video is proudly presented by Dockerized.